Hi, I'm Miss Ha, and this is lesson 1.9, Solving Literal Equations. The aim of this lesson is how can we rearrange an equation to highlight a quality of interest. And another way we're going to think of this is a variable. We're going to be isolating a variable of interest. So let's talk about rewriting literal equations. An equation that has two or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other variable or variables. Here we have our first literal equation. There is both a y and an x variable. So we have to pay attention to the directions. Solve for y. We want to isolate y and end up with something like y equals, and this will definitely be in terms of x. This expression will have x in it. So it's like solving an equation, right? We want to isolate y by itself. So first, let's get rid of this term, the positive 4x. So I'll be doing the inverse. I will be subtracting 4x from both sides. That leaves me with 3y on the left and 9 minus 4x on the right. These are not like terms, so I cannot combine them. And to further isolate y, right, this is a 3 times y. So I divide both sides by 3. And now I get y by itself. Dividing both sides by 3, this side, you could leave it like this. I'm going to show you that this is really 9 divided by 3 minus 4x divided by 3. And we can simplify 9 divided by 3 as 3 minus, and this is 4/3 x. Now, I suppose you could check your answer here by putting this value in for y and figuring out if equals 9. I am not going to go through that process. Why am I not going to go through that process? I mean, I guess I can. Sure, let's go through it. So we have 3, I'll move you up, times y, and y is 3 minus 4/3 x plus 4x equals 9. That's good practice with properties and fractions. Let's use the distributive property here, and we get 9 minus 4x plus 4x equals 9. If you want me to do that one, full out 3 times 4/3, right? This is 3 over 1. I can cross simplify, or I can go 12 over 3 is the same as 4. You might start being able to do some of these in your head, and if you can't, you're welcome to use a calculator or write out the work. So we can combine like terms. We've got a negative 4x and a positive 4x, so we get 9 equals 9. Yeah, we can go ahead and check it. Great. Example number 2, solve for x. So what we're going to see here in this literal equation is that x is in two terms that are not like terms. I cannot combine these. And so what I'm going to do here instead is I'm going to factor out an x. Or kind of do the reverse distributive property if you want to think of it like that. What I am left with is 3 plus 5z. Okay, these expressions are equivalent, this right side, because if I were to distribute and multiply each term by x, I would end up with 3x plus 5xz. Now I can see that this is really x times 3 plus 5z, so I can divide both sides by 3 plus 5z. And anything divided by itself is 1, so I'm left with x. And on the other side, I have y divided by 3 plus 5z. Maybe you're someone that when it says solve for x, you're like, I really want x to be on the left, so I can just flip these two expressions around. And there we go. Let's get into checking this one. So we have y equals 3 times y plus 3 plus 5z plus 5. I'm going to pull this z in front, z, because I'm going to use the commutative property that the order doesn't matter, that I'm multiplying. Y plus 3 plus 5z. And so I have y equals, this is over 1, this is over 1, so 3y over 3 plus, excuse me, 5z, and I have 5zy over 3 plus 5z. Well, they have a common denominator. Oh, wow, they have a common denominator. So this is 3y plus 5zy over 3 plus 5z. Oof, and maybe you'll recognize that we're going to do the same thing here, where we're going to factor out the y. And let me put that down here. We get y equals y times 3 plus 5z over 3 plus 5z. They have this common factor, and we get y as y. I'm not going to make you check these problems with these literal equations. I do want to show you how you can, but I don't want you to feel overwhelmed by this. Focus on doing the blue part. Let's do another one. The formula for the surface area S of a rectangular prism is this formula. Solve the formula for the length L. Let me just, for myself, figure out where L is in this equation. There it is. So first, I'm going to get rid of this term on the right side. I'm going to subtract 2WH from both sides to get S minus 2WH equals 2LW plus 2LH. And we're going to do this same thing where we're going to factor out an L. So the left side remains the same. And when we factor out, we divide both terms by L. We get 2W and 2H. And I can divide by 2W plus 2H. 2W plus 2H, right? Because this is being multiplied, so when I divide it, they have a common factor of that term. It's two terms. I can't think of the name of what you call that. I will get back to you on that. And so what we end up with is that L is equal to this expression. I'm going to put L first, but you don't have to. S minus 2WH over 2W plus 2H. And there we go. When I say you don't have to put L first, you could write this side first and then say equals L. And that's fine. We wanted to isolate L. We've isolated L. I am not going to go through and check this. It would require a lot more space here to do it, and I don't want to go down that rabbit hole. Next up, we have the try it, so pause until you're ready to check your answers. Solve for x. Oh, well, actually here, these are like terms, so I can combine them. And 5x minus 4x is 1x, and I've isolated x. If you prefer it to be on the left, you can have x equals y. This is an equally fine answer. Next up, solve for y. Okay, so I'm going to get y by itself. Let's add x to both sides. 3y equals 9 plus x. And then divide both sides by 3 to get y equals, well, 9 plus x over 3 is fine, but I am going to take, I'll show the work over here, 9 divided by 3 and x divided by 3, so that I get y equals 3 plus 1/3 x.